Hi. So today we'll be looking over the MakeNoise Ø-CØAST synthesizer, also known as the Zero Coast or the No Coast. It's a desktop synthesizer that lacks a keyboard. I got one right here. Here we go. I don't know if you can see that. I'll pull it back out. There we go. It's similar to West Coast synthesizers such as those from Buchla and Surge. However, it shares some things in common with East Coast synthesizers from Moog and ARP as examples. Specifically, it has the ability to track pitch at a 1 volt per octave scale, and it has the ability to be controlled by a keyboard via MIDI. Now, instead of using the familiar East Coast signal path, running a rich waveform through a voltage-controlled filter, and then running it through a voltage-controlled amplifier, the Ø-CØAST draws on West Coast synthesis by running a simple triangle waveform through distortion to add harmonic content, and then passing the final waveform through a low-pass gate that combines the functions of a filter and an amplifier in one circuit. Like other devices from MakeNoise, the design has white text on a black background, and the font, I find, is a bit hard to read. To make matters worse, it's not always clear from the names assigned to controls exactly what they do. For example, there are 2 envelope generators. The attack time on one is labeled rise, while the attack time on the other is called onset. Why not call them both attack? In addition, the user manual starts with difficult topics like programming the MIDI implementation and pairing the MakeNoise Ø-control sequencer with the Ø-CØAST. And it does this before it ever gets to explaining how to use the Ø-CØASTs via its front panel controls. It's not how I would present it, so that's why I made this 2-part video. The unit is compact. It measures 5 inches by 9 inches. Very small. It's about 1.5 inches tall. That means the controls and the different sections of the synthesizer are placed very close together. As a result, it's not always visually clear how the different parts connect, how the signal flows through the various sections of the Ø-CØAST. So to help you understand it better, I separated the 10 sections of the Ø-CØAST and moved them around to create a better way to depict the signal flow. Here's the graphic. Now, before we get into the weeds and the functions of each section, let's take a look at the bigger picture. At the top, I've shown the audio signal flow in blue and in yellow. At the bottom, I've shown control voltages in orange, green, and red. Section 1, the oscillator, is what generates the audio signals. It's got a triangle waveform as well as a square wave. Sections 2 through 5 are all audio processors. The rest, sections 6 through 10, are control signal generators and processors. There are 36 3.5 millimeter TS jacks that allow you to reconfigure the signal flow within the Ø-CØAST and interface it with other equipment such as a Eurorack format modular synthesizer. Now, 9 of the jacks have a white rectangular silkscreen background. That indicates that they are control voltage inputs. There's another one, the 1 volt per octave input of section 1 is also control voltage input. Now, the trigger, the gate, and the tempo inputs, these are in sections 6, 7, and 9 respectively. These have concentric circles around the jacks, indicating that they're intended for trigger or gate signals. The rest of the jacks are all audio or control signal outputs, with the exception of the left input to the balance control. We'll get to that. Now, having said all that, one of the fun parts of exploring the Ø-CØAST is that any output can be connected to any input. For example, you can use the audio rate signal from the oscillator as a control voltage source or as a clock. Likewise, if you speed it up, you can use a control voltage signal like a clock or a cycling slope generator as an audio signal generator. Don't be afraid to experiment. Weird patches result in happy accidents. Now, to break this into manageable chunks, part 1 of this video will focus on the audio signal path. In part 2, we'll look at the control signal generators and processors. So, let's start the audio signal path with section 1, the oscillator. You'll find it near the upper left, designated with a violet circle that has a 1 in it. Now, the coarse pitch is set by the big, large knob, right? And the tuning can be further refined with a black fine trim pot just below it. At the top are the 2 waveform output jacks. Now, the native or core waveform of this circuit is a triangle wave. But you can compare a triangle wave as it goes up and down to 0 volts. And if it's above, you can have a high output. If it's below, you can have a low output. So you can create a square wave and derive that from the triangle wave. Now, it's important to note that it's not 2 oscillators. The same oscillator produces both waveforms, which means their tuning and phase are always identical. Now, the control voltage for pitch can be set by a fixed value by using the knobs, but you can also get a note on message, a MIDI message from the MIDI input, and use the note value to set the pitch. Or you can take another signal and override the MIDI note on message and plug that into the control voltage input at the 1 volt per octave input. In addition to that, there's a linear frequency modulation input, which allows for FM synthesis, LFOs, or pitch envelopes, depending on the kind of signal that you plug into it. Now, it has a dedicated attenuator that lets you control the depth of the FM effect. Now, the triangle waveform is routed to the left input of the balance knob at section 4, where it acts like a fundamental harmonic. The square wave, however, passes through section 2, which is called the overtone generator. Now, this modifies the odd harmonics of the square wave to add even harmonics. An overtone input jack and attenuator allow you to use a control voltage to increase the knob setting dynamically. In other words, the voltage is effectively moving the knob. As you approach the maximum setting of the overtone knob, indicated by 2 exclamation points, the slope generator also affects the amount of added harmonics. Now, the next thing that happens is the signal passes to section 3, which is called multiply. This is a kind of wavefolder circuit that adds more harmonics, not by clipping, but by folding the peaks and troughs of the waveform into themselves, and that's going to create a richer wave with more harmonic content. The multiply knob has a control signal input as well that's normally fed by the slope generator. You can patch a different signal in at that jack if you want to. Now, this input is controlled by something called an attenuverter. And this can both attenuate the signal, turn it down, turn it up, but also invert its polarity, flip it over, so it's positive or negative. With the knob at 12 o'clock, the input is fully attenuated. Now turn it clockwise, and you will gradually add to the input of the current position of the multiply knob, and that's going to increase the amount of wavefolding. Now, if you turn the attenuverter counterclockwise, you will gradually subtract the input signal from the current knob position, lessening the amount of wavefolding. A large orange LED indicates the amount of multiply in effect. Now from here, the modified square wave goes to section 4 balance, and it feeds the right input of the balance knob, where it's referred to as the overtone signal. The balance knob varies the amount between the fundamental or bass from the triangle wave and the overtones or treble from the modified square wave. The balance can also be varied dynamically by sending a control signal at the balance input jack. Now, the final stage of the audio signal path is section 5, dynamics. This section uses a voltage-controlled low-pass filter / amplifier, also known as a low-pass gate. As signals get softer in a low-pass gate, they get darker as well. Conversely, as the gate opens up and the signal gets louder, it gets brighter. This behavior mimics a lot of acoustic instruments, and it allows a single envelope generator to control both amplitude and harmonic content. Normally, the dynamic knob is controlled by a voltage from the contour generator, but you can override this at the dynamic input jack. From here, the signal passes through a level trim pot, and this feeds the line output, where it can drive a pair of headphones or feed a mixer. There is also an unattenuated output in the lower right corner that can be used to connect the Ø-CØAST to Eurorack format equipment or other equipment. Now that we've covered the audio path, let's examine the control signal generators and processors in part 2. I'll put a link for part 2 in the comments below. I hope you found this tour helpful. If you did, give the video a like and subscribe to the channel for more music and content like this. Thanks for watching.